Thank you very much. I appreciate the effort of the organizers in giving me this rare opportunity to present our work, assessment of PM 2.5 and PM 10 pollution around scrap metal recycling industrial area of Nigeria. My name is Tesleem Kolawole from Osun State University, Osun State, Nigeria. This work was supported Larry collaborated with Professor Herman and Dr. Wadinya Fomba, both of the Institute of Leibniz Institute of Tropospheric Research, Leipzig, Germany, and other colleagues from Nigeria. As we all are aware that particulate matter pollution is a major global concern because it affects the health of human beings. And recently in 2019, the Health Effect Institute reported that 4.4 million people died globally as a result of long-time exposure to PM 2.5. As we all know that the source of PM 2.5 could be geogenic or anthropogenic. Mainly anthropogenic contributions is coming from industrial emission, traffic emission, waste incineration, and so on and so forth. And this could cause health implications on human beings. In Nigeria, there is enormous demand for metals, and because of that, metal recycling plants or factories were built in Nigeria. And the source of this, the major material for this factory is metal scrap metal materials that are used in order to produce steel. And this has caused a lot of havoc or pollution in the environment because where they are located, they are not well planned and no mitigation to abate such pollution in our environment. So this work look at the assessment of PM 2.5 pollution and scrap metal colony. And the objectives are as follows: determination of mass concentration of both PM 2.5 and PM 10, water soluble ions in both particle fraction, to also determine carbohydrates, sugar content of the particulate matter content of the PMs, and also to determine the sources of these pollutants. The sampling site and analysis. Like I said earlier, that a lot of metal recycling factories were built in Nigeria in order to make up for the demands of non-ferrous and ferrous materials in Nigeria. The study area has the highest number of metal recycling plants we have in Nigeria. And the reason being that the area where this metal are located has a gas pipeline, and the gas pipeline is usually used as a source of electricity in order to power the electric furnace where the metal processes are being carried out. Apart from the metal recycling plants located in this area, there are some other manufacturing factories such as cement factory and petrochemical depots are also located in this area. In other words, this area has a lot of pollution sources that could affect the environment. 2 decades ago, when this area, when manufacturing, better recycling manufacturing plants were located in this area, the area is more or less an rural area where we have scanty population there. But now it's been populated, it's turned to urban center because those factories has really brought a lot of investment, so that attracts urbanization in this area. And this has that's consequences. There's a lot of consequences. Next slide is a sample collection. This work was carried out. So sampling was carried out in this area in order to monitor the air pollution in this area. So low volume sampler was used. Double stage giant stack sampler was used, and this contains 2 major components: the pump and the sample collector. Detail of this, the process or detail of this the process can be found in Manhot et al. 1993. The sampler is a low volume sampler, has 2 stages, contains a fine and the coarse stage. The fine corresponds to the PM2.5 stage, while the coarse stage corresponds to PM10. The samples were collected by gravimetry analysis on pre-weighed and preconditioned polycarbonate nuclear pore filters, which is 47 millimeter in diameter. Sample duration was for 24 hours during the wet season, as a period of October 2020, and in dry season, that was March 2021. The sample collection was done in a week, was carried out in a week in both seasons. Then the sample, the filter was now analyzed for its elemental components, water-soluble components, water-soluble ion components, and also the sugar content. TXRF was used to analyze for metals. Prior to this analysis, 4.4 millimeter, which corresponds to 1% of the nucleus of the filter, were pushed out and were placed on TXRF's sample holder substrate. After which, HNO3 was added to the filter, and also the gallium yttrium also which serve as interactant that was also added. The solution was left to evaporate at 100 degrees Celsius, and thereafter the substrate containing the particles on the foils were measured. Detail of this sample preparation can be found in Fumba et al. 2013. Also, ion chromatographic techniques was also used in order to determine water-soluble ions. Filter were extracted. 25% of the filter was extracted with 30 ml water. The extract was shaken via shaken, and sample extract were filtered through 0.45 microns one-way syringe filter to remove insoluble material prior to ion analysis. The analysis was performed for cations such as sodium ion, ammonium, potassium ion, magnesium ion, calcium ion, while the anions constitute chloride ions, sulfate, and so on and so forth. The mass concentration of PM 2.5 and PM 10. This slide showed the time series of mass concentration of PM 2.5 and PM 10 in both wet season and dry season. And it was observed that the highest concentration was observed in the dry season for both PM 2.5 and PM 10. However, daily PM 2.5 average did not exceed the 24 hours World Health Organization air quality guideline in the wet season, while in the dry season, they exceeded air quality guidelines in the dry season, both for both PM 2.5 and PM 10. Also, the average percentage fraction of PM 2.5 in the wet season and the dry season for this study were 1/4 of the total sample analyzed. Meanwhile, the PMs are mainly sourced from industrial and other anthropogenic and fugitive dust from soil. Our results is also compared with previous work, especially the work that is germane to this work. There is similarity between our work, especially in the dry season, PM 10, similar to the work of Zoran et al. 2020 in Milan, and also Tue HE2a 2012 in Taiwan. Yeah. When this work is compared to the work of Olalehan et al. 2019 and Olalehan et al. 2009, let's realize that our value or result is comparatively low compared to what did 2015 and 2009. However, the result of our work is far higher compared to the Zhang et al. 2018 and Fomba et al. 2019. Water-soluble ion. The result of water-soluble ion shows seasonal variation in both anion and cation in both seasons. They are comparatively, the water-soluble ion in dry season is higher compared to the water-soluble ion in the wet season. There are correlation between most of the anion and the cations and some prominent metals. They have almost linear regression. We compare sulfates to sodium ion. And of course, nitrogen to sodium ion, you have linear regression. And this indicates that nitrate and sulfate salt are used. Nitrate and sulfate salt are used in foundries in manufacturing both ferrous and non-ferrous metal. Therefore, the presence is as a result of MRF processes. Then also carbohydrates, so sugar, there's a variation, there's a seasonal variation between sugar. There's a strong positive correlation between levoglucosan and potassium ion. There is somewhat linear regression between levoglucosan and potassium ion. The presence of levoglucosan is an indication of biomass burning in the study area. Elemental distribution. Also, there is significant variation between PM2.5 and PM10 in both seasons. And of utmost importance, the concentration of iron, zinc, lead, plus potassium and calcium. Concentration of potassium and calcium. They are the most prominent metal in that area. And the reason is not far-fetched, because lead is, of course, lead, zinc, and lead and zinc, they are alloy metals. That's when their base melts, they have very low boiling point and they expand. So after all, now look at the concentration of lead, iron, zinc, and calcium in that area. Look at the time series to compare this result, and it was realized that these metals are very higher in rainy season than dry season, and PM2.5 and PM10 is also higher than PM2.5 in all these prominent metals. Also, there are positive, very strong positive correlation between all the metals, and this is an indication that from the same source. Similarly, as linear regression between manganese and iron, which is as a result of could be as a result of cluster relationship or cluster source, and in the case of lead and zinc, it's as a result of anthropogenic sources. Principal component analysis was also performed in order to classify the metals so as to know their sources. 3 factors were identified. Factor 1, composed of potassium, calcium, titanium, manganese, iron, zinc, copper, nickel, and hafnium. And their PC load is between 0.66 and 0.94. And of course, we have weak load of lead, which is 0.56. And their presence is attributed to alloying materials and expanded pins that normally becomes volatile during melting processes. And of course, selenium and molybdenum. And this could be as a result of fossil fuel combustion in that area. While factor 3 are solitary elements, which is strontium, which is ascribed to dust emitted from cement factory in the study area. Thank you very much.